to advance the study of mathematical ecology and epidemiology within the university. I would appreciate us that we applaud Professor Kesh as he also presents his keynote speech. Thank you. Good afternoon to all of you. To go my lecture, I first hear something about Nigeria from my point of view. When I landed in the airport, I first saw the airport is greenery. I visited many places. The airport is not greenery, but your airport is greenery. And entire road is mountain and greenery. That's why I love Nigeria, because we love greenery area and because we live pollution and other. Now I'm going to talk my lecture. I will talk in influence of volatile on improving hand thickness. What is plant volatile or parts? When we plug a flower or leaf, they will cry. Just like us, if anyone beat us, we also cry. But plant also cry. It says volatile organic content, and this is the our aim. Make a model how to improve the plant fitness. The population is what will happen when a plant is damaged by insect herbivore. To take need of such insect herbivore, to plant defense against herbivore insect through direct, indirect, and indirectly by releasing chemical compounds, whatever with the insect herbivore strategies, if they are lateral. We have used the pesticide to take this attack, but in natural system, there is a mechanism, defense mechanism of there. Just like you can go to the schematic diagram, when plant attacks the herbivore attacks the plant has defense mechanism. From there, one is direct defense mechanism, and another is indirect mechanism. And then plant take volatile organic compound in the air and attack the predator to kill the herbivore. There are two types of defense. One is direct defense, which we can see very easily: physical defense, stone, spine, and chemical defense like resin, odor, or toxic. And indirect defense is domatia. You see in the plant, there is some place where ants and carnivores are staying there, and they defense from their herbivore. And food board is extrapolar vectors and volatile organic compounds. We now mainly interested in volatile organic compounds. I tell you two papers. One is competition induced volatile and one is other is diffuse. This is the schematic diagram of this model. We consider two plants. They use as common resources, and they compete each other, and herbivore attacks both the plant X1 and X2, and both of them emitted induced volatile emission and attacks the natural enemy of the carnivore, of the herbivore, that is carnivore chain. This is the modern formulation. R1, R2 is the growth rate of this equation. X1, A11 X1 or A22, X2 is the infra-specific competition, you know, if the area is so small for resources of the food, they compete each other. That's why we take it in consideration as A11 and A22 and A12, X2 and A21. This is the competition coefficient. Both these species will compete with each other. If we fight each other, our energy will lose. That's why we consider this negative part. And another one is C1 and C2, that is herbivore attack and destroy the plant, that is C1, X1Y and C2. And DYDPT is the D1 is the death rate and P1, P2 is the food conversion efficiency of the predator species, and when carnivore attacks the predator, that sum is considered here is minus Ct by Z. And DZKB is the Z and Ct is the food conversion efficiency, and lambda 1, lambda 2 is the attraction factor of plant volatile to the carnivore to survive themselves. You know, as mathematician, you need to boundedness for the system to analyze the model. Either the system is persist or global stability, not. That's why you needed to boundedness. So we first done the boundedness is the condition of the boundedness, and we get to analyze any system, we have to find the fixed point, that is stationary point, and here we get 6 equilibrium point, and the existence condition of these 6 equilibrium point is here. Now, through Jacobian matrix, we analyze the local stability analysis of the system, and we get the following condition to stability. Now, throughout the whole analysis, we choose the parameters, follows to other ways to numerical simulation. To go to the numerical simulation, we pass global sensitivity analysis, which parameter is sensitive for fitness. You find here, and you know the global stability analysis, you see that competition coefficient A21 and A22, A21 and A22 has effective role for global sensitivity analysis. Now, after local stability analysis, we persist. What is the meaning of persistence? Persistence meaning the system will stable in future time, that is t equal to infinity. And we find the local analysis that the equilibrium point E4, that means X2 species T equilibrium point, and E5, X1 T equilibrium point is globally stable for certain condition. And assuming the lemma T and 4, we find the system 1 will persist. Now we derive the global stability analysis by higher temperature pointer prediction criteria, and we get the system is global. Now we go to the numerical simulation. You see the system is equilibrium at the point 0.744 and 0.87, and other of the system is global stability, and A and D represent the triangle diagram that the system is equilibrium point stable. Now, if we change the parameter A1 value, we find the bifurcation diagram of the system with respect to parameter A21 and indicate the dynamics of the first population, which is from stability to oscillatory area, and again becomes stable as equal across the critical value 0.75. Note. This is the two parametric bifurcated diagram A21 minus lambda 1 plane the region with red color represents the stable state of the system along the interior equilibrium point. There is very narrow yellow region, light yellow region of a bistable stable of the parameter space where E4 stable along with the interior equilibrium point EC. And deep yellow color region denotes the stable region around the fixed point E4. In white color region, E6, that is the interior equilibrium point is unstable. This parameter space A2 lambda shows that there is lies a chance of two times bifurcate. With the numerical simulation of this result, and this is the following the bifurcation diagram, and you get the T. The bifurcation diagram of X1 with respect to lambda, this figure shows that the system one is unstable around E6 as a critical value of lambda and stable for greater value of the critical value of lambda 1. A Bob bifurcation occurs at the critical point lambda 1 with the inset represent the time evolution of the system and unstable creator at lambda 1 is 0.4. Lambda 1 is 1.3. What is lambda 1? Lambda is a volatile organic compound, the emission will attract the carnivore. If the volatile organic compound is high, then the system will be stable. Otherwise, this is unstable. Now, this is the discussion part. The plant composition strongly resembles community dynamics. We get 5 boundary equilibria with 1 interior equilibria. And transcritical bifurcation occurs to change in herbivore vertebrates and carnivore attraction. Hog bifurcation arising in increasing interspecific competition A to R causing temporary oscillate. Increasing volatile organic compound of lambda 1 stabilize the system and improve coexistence. B. That means A. This is the following references. Okay, we will discuss. This is the publication in modeling of a system size and environment. And now I am going to the second part that where carnivores attack the herbivores, herbivores try to reduce to defend themselves. That's why I choose a model that impact of volatile mediated indirect defense response of plant and herbivore will reduce in Tri-Trophic cascade. This is a Tri-Trophic system, plant, herbivore, carnivore. The herbivore attack the dark light, that is, they attack, herbivore attack the plant, carnivore attack the spider mite, the volatile organic compound, then find the signals, let the mites come, and they will kill the herbivore. Now, the form of how can we form the model? The red color indicates the predator. The predator is carnivore, and green color, that is herbivore, insects or prey. And we find the zone A and zone B. A zone A represents the area where prey species can utilize the refuge to keep them degree of protection from predation. And in zone B, predator can predate their prey. Never the predator can kill the prey here. That's because they are reduced or now we form a three-dimensional model. See, we consider the predator functional response is Holling type 2 and carnivore functional response there is Holling type 3. This is a combination of Holling type 2 and 3. And because when herbivore may be invertebrate and carnivore may be vertebrate So that's why we consider two type of functional addiction, Holling type 2 and Holling type 3 functional addiction. Let's see. Sorry. See, you know the parameter meeting here, I discussed here, but here consider as A. A means diffuse constant parameter. Okay. Now you find the role of the diffuse and we find the boundedness of the system, and throughout the analysis includes the parametric values, and we continue with try to global sensitivity analyze. We consider here is A is a sensitive parameters and other sensitive parameters here to find the which parameter is more sensitive to system globally stable or not. That's why at first we find the persistence of the system by a certain condition to see less than K1 alpha B in all population system will persist, and we had a global stability by two theorem applied, high dimensional benediction criteria, and the second compound matrix. And we find the system is globally asymptotically stable. Now, go to the diagram without indication, that is mu equal to 0, we get the system behavior by bifurcation diagram very AB where diffuse constant A. Next, this is the we find the mu is equal to 0, classical bifurcation occur of the system. This is the phase footprint and basin of Patterson. Red region is a stable treatment and orange region is oscillatory behavior. In your progress analysis, mu not equal to 0, mu is 0.01, and mu not equal to 0, we get the following result. Effect of herbivores by the system, mu is equal to 0.01. Now, we have opted to bounded equilibrium and one equilibrium where the system is persistent if natural death rate of herbivores is less than a certain threshold value. We have added robust analysis by highlighting benediction criteria of Biomathematics. Indication rate of natural means if we induce large volatile, decrease the density of herbivore and increase the biomass of plant. Herbivore reduce A is responsible to make systems to be more stabilized. These are following references, and this paper is published in the differential equation and dynamical system. Now, I am going to conclude a remark. You see, in peripheral and other, we use this pesticide to remove the herbivore from the herbivore atom, which most of the pesticide moves to the earth, and through plantation, we again eating these vegetables, that the vegetables which you are eating in daily life are also affecting us by using pesticide, but even we can use the indirect defense mechanism of plant protection themselves or insect instead of using pesticide. And the volatile organic compound entire world now try to use the biologically feasible volatile organic compound as pesticide, or they purchase ants and other things for their tomato pit or cucumber pit to from attack on the herbivores, as because the ant, you see the ant and tail in the pit in the tomato leaf and cucumber leaf, if they in US and other they use the ant as a pesticide, as because they when the trees begin grow, they send to they purchase the ant and say send to the field that will save the tree from the herbivore. So if we can use the indirect effect plant for protecting themselves from insect instead of using pesticide, then it may be benefited for environment as well as even beings also. Thank you. There are any questions? Any questions?
Thank you very much, Professor Dipak Kesh, for that wonderful presentation. And so we've listened to the keynote talk by Professor Kumar, and particularly he has touched on an interesting area when it comes to the plant biology. And so we see what the competition as when we talk about the herbivores and also the carnivore competition, and we see how mathematical modeling has come into play in depicting that from real life scenario, and then addressing a major problem and challenge we are facing in our environment, that is the indiscriminate use of pesticide in the environment, and then how we can actually introduce some kind of intra-specific competition on the biological space to see if we can reduce the harmful effects of pesticides. So thank you very much, Prof, for that wonderful talk. So right about now we'll be taking questions. So I don't know if we have questions on site and online. If you have questions, let me just see your hands up. Questions? Also help us immediately with the question online.
You can go to the
If anyone is interested to do the work this field, and because this is a great goal to evaporate pesticides, we can go through the papers, and because we are interested, of course, with modeling from the plant dynamics, from the biological field.
Of course.
And because with the mathematician trying to model in a DSP. And I have already asked to get the delivered in the biological people, how can we remove the pesticide and activate the carnivores? I have done a thesis of this area. One of my scholars, Dr. Ritika Mandal, she is now in Thailand. He is doing another research work is there. He is also collaborator of me. And if anyone is interested, you go to the Google Scholar and write the name of Dipak Kesh, not Kumar. Then you get all the papers. If anyone interested, you can mail me. I can help you to speak. I have no problem. That's because we are in the same boat as a mathematician. We try to improve your mathematics and the public for the later in the Thank you.